Hello again. This is a review of Chapter 2. You should have your notes with you, of course, and study them thoroughly. Now, Chapter 2 begins a series of chapters on the chemical context of life. In fact, that's the title of the second chapter. Now, in the first section, we talk about elements. Elements are made of one kind of atom. There are 92 naturally occurring elements. 25 or so are essential for life. Of those, 4 of them, carbon, oxygen, hydrogen, and nitrogen, make up 96% of a living thing. But these 4 elements don't exist as free elements. They exist as compounds. For example, water is a compound. It's made of oxygen and hydrogen. So a compound is composed of molecules, which involve atoms binding to other atoms in a single unit known as a molecule. Now, with atoms, under Roman numeral 2, you need to learn the differences between protons, neutrons, and electrons in terms of their charge, in terms of their atomic mass, and where they are located in the atom. There's a little chart there in your notes. Now, atomic number of an element is the number of protons in the atom. Every element has its own atomic number. No 2 elements have the same atomic number. The atomic mass is the number of protons plus neutrons. Okay? Now, it is possible to have isotopes. Isotopes are different forms of an element having a different atomic mass, the same atomic number, so they differ in the number of neutrons. Some isotopes are radioactive. Now, energy levels. We move on over to page 36, and it shows you a partial periodic table with some circles and some dots. These are illustrations of the energy levels of electrons. Electrons orbit the nucleus. Now, the number of electrons in an atom is dictated by the number of protons, because protons have a plus charge, electrons have a minus charge. But what you see here is that electrons occur in levels. The first level or shell can hold up to 2. It can hold less, but it can't hold more than 2. So if you have more than 2, you got to have another level. So that level holds up to 8, and the third one up to 8. Again, they can hold less, but not more. Now, if the atom does not have a full outer shell, then it will do something about it. It's going to want to react. We call this the octet rule. An atom is chemically stable when its outermost shell is full. So if you look on page 36, you'll see helium, neon, and argon. Their outer shells are full. These are the inert gases. They do not tend to react. But the others will. They're going to want to do something about it. They're going to react with each other and form bonds and molecules. So chemical bonds and molecules. They do this to satisfy the octet rule. Now, ionic bonds, look on page 39. An ionic bond is the attraction of oppositely charged ions. On page 39, we have sodium and chlorine. The sodium atom only has 1 electron in its outer shell. It's going to want to lose it and then become the sodium ion or electrolyte with a plus charge. The chlorine atom will gain that electron for the same reason, to fill its outer shell, and then become the chloride ion. They attract because now they're oppositely charged ions to form a salt crystal. So ionic bonds are found among the salts. Covalent bonds, you look on page 38, a covalent bond is a shared pair of electrons between atoms. And atoms will share electrons in order to satisfy the octet rule. So you can see the shared pair of electrons binding together hydrogen gas, oxygen gas, which actually is a double bond, the water molecule, and methane. Now, when it comes to sharing of electrons, we can compare 2 molecules, water and methane. Here's methane. There's water. Both small molecules, not that different in size. In the case of methane, the sharing of electrons is equal throughout the molecule. See, the electrons are orbiting the whole thing. They're not just sitting still like in the drawing. But oxygen's a little different. With water, oxygen has a high electronegativity, which means that oxygen is greedy when it comes to sharing electrons, meaning that the electrons are going to spend more time with the oxygen, less time with the hydrogen. And since electrons have a negative charge, that means this end of the molecule is going to be partially negative, and this end is going to be partially positive. Now, if we have another water molecule, same thing, we're going to have the attraction between these molecules. Now, because this molecule has a minus and a plus pole, this is referred to as a polar molecule. And this weak attraction between polar molecules is called a hydrogen bond. And believe it or not, that affects the properties of water. The hydrogen bond is not strong enough to form a molecule, but it is strong enough to affect water. And that takes us right into chapter 3.